My inspiration for this project was actually a homework assignment that we had a couple months ago, the one where we had to design a program to randomly generate a melody. So for this project, I decided to expand on that by having it randomly generate not just a melody, but an entire 4-part harmony. Not only that, but you can pick the key, the meter, and the tempo, and it will actually output the samples to a raw file for playback. So here you can pick the key signature. Negative numbers are flats, positive numbers are sharps. You can pick 0 to have no key signature, or you can pick 9 to quit. So I'm going to go with -3 because I want to pick C minor. For minor, I pick 1. I'm going to go with a meter of 4/4 and a tempo of 180 beats per minute. Maximum length of 1 minute because I don't want this to take forever when I play it. And sure, let's print the chords. So here you have the total number of samples. Sample rate is always going to be 22,050. The total length, you've got it right here. Total number of measures, lowest frequency, highest frequency. And when you scroll up, you can see the different chords in block chords written in solfege. So this is the part of the code where most of the generation occurs. Every song starts the same way, but after the first chord, things start to diverge. All through here, you have the part of the code where the rules are to determine what types of chords can and cannot be selected. All the way through here, the code follows those rules and eventually gets to its selection. Here, a new chord block is dynamically allocated. Here, its parameters are set. And here, with this function voice lead, is where the voices are rearranged into their final configuration. Some notes are locked in place, namely primary and secondary leading tones that resolve to the tonic or the dominant respectively, sevenths that resolve downwards, and whatever note happens to be in the bass. However, the remaining notes can be rearranged pretty much at random as long as they don't break rules such as not doubling the leading tone and not having parallel fifths. Finally, if a perfect authentic cadence is detected at the end of a measure, and it's not too early in the song, the success condition is triggered, and the loop breaks. Once the loop exits successfully, the program writes out the actual notes in each voice. For the most part, the program takes from the corresponding voice and chord blocks, but at random, it will add extra flavor notes, particularly in the soprano. Once the notes have been written out, a nested for loop converts them into breakpoints, the lowest and highest of which may be compressed towards the middle to keep them within a certain range. Then these breakpoints are fed into combined samples, which calculates the appropriate amplitude for each sample and outputs it. Then these samples will be output to your raw file. So why don't we have a listen to that file that we created a few minutes ago?